right, here we go. We're going to do 4-5. This is the last of, I guess, what you could call the normal congruence theorems. We're going to do some other ones in the next section. But this is kind of the last of like the quote normal ones, whatever a normal one is. So let's draw a triangle. There's only one of them that we're going to do. And let's see. I'm just going to draw the triangle like this. Like this. Let's see, about like that. And like that. Nothing special about it. It kind of looks like a right triangle. I didn't really want it to look like a right triangle, but that's okay. No biggie. I'm going to group it. Going to copy and paste it. All right. Now, can I say that these triangles are congruent right now the way it's written? No. Now, I did copy and paste it, so they probably are congruent. Not probably, they are. But just by the information that they give you, no, there's no way that you can say these triangles are congruent. You can't just say, well, they sure look like it. You can't do that, all right? So you have to be told stuff. And then you got to figure out some things. So they tell you that AB and DE are equal to each other. They tell you that AC and DF are equal to each other. Now watch. Every one that we've done up to this point has had at least one angle. This is the one that doesn't have any angles at all. So what else do you think that they tell you is equal? Give me letters. BC and EF. Good. It's not? It is. Well, it's not B and C, but it's BC and EF. All right. Right, he said and EF. I heard him say that. It's fine. We're good. All right, whatever. All right, so anyway, these two triangles, the only thing you know about it is that all three sides are congruent to each other. All right? That's enough. That's enough to say that these triangles are what? Congruent to each other. Right, we don't say they're equal, we say they're congruent. So what's my congruent statement? Yeah, let's go ABC, might as well. So triangle ABC, right, triangle ABC is congruent to what? Triangle what? DF. How do I know it's DEF? Well, I mean, they look like they're not twisted, they're not flipped or anything like that. But let's see how we know exactly which one goes with the A. So let's take a look at the A. Because what if it was flipped and twisted? Sometimes it's hard to tell which one goes with what. All right? So the way we can do that is to see what side is opposite that angle. So look, angle A, right? I got to find out, is it D, E, or F? Well, you know it's D, right? Because they look like they would just sit right on top of each other. But let's see for sure, okay? What is angle A opposite? Angle A is opposite a side with what? BC, but with 3 tick marks, right? So what angle is opposite the 3 tick mark over here? The D is. Do you see it? See, the A is opposite the 3 tick marks, and the D is opposite the 3 tick marks. So that's why we're going to put a D right there. What about the B? The B is opposite what? 2 tick marks. What's opposite 2 tick marks over here? The E is. All right? And of course, what's the only thing left? The F. And it also works, right? C is opposite 1 tick mark, F is opposite 1 tick mark, and that's how you do it. So that right there would be your congruence statement. All right? Now, what do you think the reason is? Why are these triangles congruent to each other? There's no angles, right? There's no angles given to us. So what do you think we're going to call it? We mentioned this yesterday as you guys were walking out the door. That's it. You call it side, side, side. Now, we write SSS, but we say side, side, side. Okay, so when we verbalize it, we say side, side, side. When we write it, we don't have to write all 3 of those words. We just put the first letters just to make it a little easier. So there's the congruence theorem, or the congruent statement, I should say. And here's the reason. This is the reason why they're congruent, because of side, side, side. So let's review briefly before we go our congruence, either postulates or theorems that we've learned so far. All right, so let's just review so we can remember some of these. What were the 2 postulates that we learned? Okay, they didn't have to be proven. Do you remember what they were? Side what? Angle, side. That was one of the postulates. And what was the other postulate? No, angle, side, angle. So those are my postulates, okay? Then we learned a couple theorems. We've learned today was the second theorem. What was the one you said at Judea? What was it? No, the one you just said earlier. Right, angle, angle, side. Okay. And what's the one we learned today? Side, side, side. Now look, I'm going to show you something. Try to be grown up about this, okay? Don't be silly about it. First of all, the first one's not silly, but there is no angle, angle, angle postulate or theorem, okay? If you think about it, let's watch. Let's look at this real quick. Is there any angle side, side? We're going to talk about that in a second. That's what I want you to be grown up about, which I don't have much hope. All right. All right. Now let's take a look at this. Copy and paste. Now watch this. All three. Right. So watch. Everybody look here. Everybody look here. Shh. I want to show you why there's no angle, angle, angle. All right. This is the easiest one to do. I'm not going to do this with the other one, but on this one, if that angle is equal to this one's equal to this one's equal to this one, does that mean they're congruent to each other? It does not mean they're congruent to each other because I could always do this. Look. Look, are the angles still equal? Yeah, that's 60, 60, and 60. What's that? 60, 60, and 60. Are they congruent to each other? No. So can you have a congruent statement with just all three angles? You cannot, okay? Here's another one you can't. I'm not even going to write it the way you said it just because everybody's going to giggle and just be dumb. You are. I'm not going to write it. So I'm going to write it like this. There is no, listen, there is no side-side angle, all right? Now, I'm not going to show you, especially because the bell's about to ring, but I'm not going to show you why that's not true, but just understand that there is no side-side angle because if you read it in the reverse, which I'm not going to write down, I'll leave it to your imagination, all right? If you read it in reverse, okay, this is not, now listen, this is not why it doesn't exist, all right? It doesn't exist just because it says a word we're not really supposed to say, all right? But it just doesn't exist. And there's a way that I could show you that, but I'm not going to show you that today. But there is no side-side angle, or there is no what? Angle, side-side. There's no angle, side-side, all right? And there's no angle, 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 all right? But these are what we have so far. We're going to learn some more with right triangles in the next lesson, but that's it, okay? So those are your reasons why triangles can be congruent to each other. Now, what's important? What's important about side, angle, side? That the angle is where? It's the what? The angle is the included angle. What's this side? This is the what? Included side. What's this side right here? Is it? Is it the included? Is it in between the two angles? No, it's the we say non-included, okay? This one doesn't have any inclusion because they're all the sides. All right, your homework is numbers 1 through 6. 1 through 6 on that section. It's section 4-5. All right, that's your homework, 1 through 6. Have it done by Monday.